Hello and welcome to Engineering Key Tutorials. So in the video I'm going to show you why electric-based cars more stable than ordinary engine-based cars. First of all, in this study I will show you allowable velocity according to stability only, which is the sliding and overturning or tipping. But there are other parameters for allowable velocity according to something called stopping side distance. We will talk about it in transportation engineering videos. As you can see, if the car travel in circular path like this in the figure, it will affected by centripetal force providing due to diffraction between the tires and the road itself. If you look at F2, it is bigger than F1 because F2 is bigger than F1 because the friction force depends on the normal force. And if you look at N1 and N2, you will find N2 bigger than N1 because something called centrifugal force, it opposite direction of the circular motion. It has value mv squared divided by r, which is also m times omega squared times r. So the centrifugal force or centripetal force directly proportional to the radius of the circular path, not inversely proportional. Because if you convert the tangent velocity to circular velocity omega, you will find the equation equals m times omega squared times r. So if we have more centrifugal force, we will provide more overturning moment or tipping moment, as you can see. If this overturning or the tipping effect is increased, the normal force at N2 will be bigger than N1, as you can see also. Okay guys, let's study the stability due to sliding. As you can see, M times V squared divided by R, the centrifugal force, should less than mu, which is friction coefficient, times N1 plus N2, which is the total amount of the friction force. If the centrifugal force mv squared divided by r less than the friction force or the total friction force, so the car will not be slide. Then if you look to the final allowable velocity due to sliding, you find v equals should be equals or less than square root of r times mu times g. If you look to this allowable velocity, you will not find the height as a parameter in the equation. The height from the center of gravity to the edge of the tire. So it's not important for our comparing between electric cars and engine-based cars. The most important one is the tipping check or the overturning check. If we take the torque or the moment around the edge of the tire, so m times v squared divided by r, which is the centrifugal force, times h, which is the arm of the moment or the torque, it should less than mg, which is the weight of the car, times L divided by 2, which is the R of the weight. If you substitute in the equation and rearrange it, you will find the allowable velocity due to overturning equals to square root of R times G times L divided by 2H. Here, as you can see, H is play important rule in this equation. The more or less h, or the more or less distance from the center of gravity of the car to the point of overturning, or the more allowable velocity we will have. So that's providing more safety at curves or any changing of the direction due to any emergency. So as you can see, the distance from the center of gravity of the car to the overturning point or tipping point, it's important to providing more safety at emergency cases or in curves and something like that. So this is how electric-based cars more stable than ordinary engine-based cars. Okay, hope it's helpful information, and see you later in next videos. Bye.